Topic name is dehydration of alcohols. What generally happens here? कि suppose if I have an alcohol and if I use here concentrated H2SO4. H2SO4 being an acid will release H plus. This H plus will go and attack on the lone pair of OH minus. What will happen here? It will form OH2 positive ion. Now what happens? This water gets eliminated and a carbocation is formed. As we know that carbocation, if possible, will rearrange for more stability. Since here no rearrangement is there, hence we'll move on the further step in which OSO3H minus being an base will come and attack on beta position and will take away the H, leading to the formation of an alkene. So what majorly happens when 1 degree or 2 degree alcohol reacts with an concentrated acid? It generally gives you an alkene. We will move on to further questions. Suppose if I am having this question and I am using here concentrated H2SO4, what will happen? This OH will be converted into OH2 positive, leading to the formation of a carbocation. Carbocation stability is checked by here hyperconjugation. We know that at this place it have 4 alpha H, and if it will rearrange here, then it will have 3, 3, 6 into 8 alpha H. So due to increased stability, this carbocation will shift here. Which shift will occur? Hydride shift. What happens here? Hydride shift. H from here will move to this place, and this plus will move to the next place. Okay. Now what happens? We have alpha positions and beta positions. Let me check here. If we see this positive charge, we can remove H, that which OSO3H minus will take away from either this position or this position. We have 3 beta positions. So if I move further, we are going to see that there are 2 products that are formed. One is, if I remove H from this place, we will get this alkene. And if I am going to remove H from this beta position, both are same, so hence they will get alkene at this position. What happens here? We will say that this one is major product, this will be minor product. How I am going to decide it? Because of stability of alkene. What happens with stability? Say here, this alkene have 1, 2 and 3. Actually, if I am saying it have 9 alpha H, while if I see this alkene, it have only 5 alpha H. So stability of alkene is decided by the number of alpha H it have, or we can say by Sadzev rule. What Sadjeff rule have told us? What Sadjeff have told us? Sadjeff stated that the most substituted alkene will be more stable. What does it mean? See this alkene. This alkene have 1, 2 and 3 alkyl groups, while this alkene have only 2 alkyl groups. So the major product will be Sadjeff product. What will be Sadjeff product here? The most substituted alkenes. What is most substituted alkene? Which will have more alkyl groups, or in simple language if I say, what happens? Which have more number of alpha H. So what will be the major product here? It will be this one alkene. Okay, what is the name of this alkene? We can go on naming. It is 2-methylbutene. So 2-methylbutene will be your major product. Okay, one more question will do. Suppose I take this question. Suppose I have this alcohol and the same process is going on, H plus comes an attack here. What will happen? Just see. We are going to see a carbocation here. Now what will happen? Ring expansion will take place, because as we know that 6 carbon ring is more stable than 5 carbon ring. So moving ahead, what will happen? Ring will expand. So this will go here and the positive charge will come this side. It becomes a 6 carbon chain ring. So let's start here. It is the 6 carbon with a methyl and a positive charge adjacent to it. It will again reshift. So what it will form? It will form a positive charge here. Again the concept is of alpha H, and third degree is more stable. Now what happens? Again the base, if we say that OSO3H minus, it comes out. Now where we have H beta positions, here beta, this also beta, this also beta. So this both positions are same. So what happens? One alkene this will be formed and one alkene this will be formed. Which one is more stable? Again this one will be major product, and of course this will be Sadjeff product too. Why it is Sadjeff product? Because of majorly substituted. See how much alpha H is here? To this side, to this side, to this side. If we are seeing on this alkene, it have only 2 and 2, 4 alpha H. So what does it mean? That on dehydrating alcohols, alkenes are formed, and in these alkenes, Sadjeff product is more stable. I hope it is clear.